All right. Hi. This is my WE475 final product. It's on the PDU pathway system. And here is the PDU pathway. You can see those are the influxes and outfluxes of the chemicals. And the reaction is based on the Michaelis-Menten kinetics. So this is the model we are using. And then this part can simulate this ODE system using a SciPy package. And this part are the all the chemical constants like the reaction rate, the Michaelis-Menten constant, and the equilibrium rate. And for the initial condition, we assume there is one high concentration of one substrate, and then all the other things are nearly zero. And we make the simulation. And our goal for this machine learning project is to find if we can change this to Michaelis-Menten constants, is it going to give the same qualitatively the same behavior as we see from the actual experiment? So the goal is to see what kind of combination of these two Michaelis-Menten constants can give us the a maximum toxicity below the threshold. The threshold we set is to be 100 in this case. So we are varying two parameters, and we want to find what is the boundary, and one side is the toxicity is above the threshold, and the other is below the threshold. So we generate 1,000 sample data based on some literature of the possible feasible Michaelis-Menten constants. And then we run the simulation 1,000 times based on this 1,000 Michaelis-Menten constants. And after running the data, we collect the data and we normalize the data. And then based on if they produce a toxicity above 100 or less than 100, we label them by -1 and +1. And here is the plot of that. So we can see, we should expect to see a vertical decision boundary. The left-hand side is the, the feasible one, and the right-hand side is the non-feasible one. So we define our model. It should be a linear model. We want to see a vertical boundary. And then we use the softmax for the nonlinear activation. And then for the gradient descent, yeah, we use the gradient descent, and we also use the Wolf competition to make sure the it's a descent direction. And then we initialize the coefficients and then run gradient descent on 1,000 iterations and 0.1 as the learning rate. And the result is here. So based on this result, we can recover the decision boundary is kind of a very vertical boundary. And the x-intercept will be small because doing this division here, the x-intercept will be very close to zero. And that matches with our just naked eye observation. And we also plot the number of misclassification. So it drops very quickly. Here is about 20 or 10, and then it slowly still decreases up to at the end, there are only 7 misclassification, which I think is a good result. And that's it for the project. Thank you for watching.